Turning. Okay. Hi, everybody. Welcome to this DBAMA session on ReplicaSet and InnoDB cluster with Mr. Shell. We have Miguel from MySQL team. And so, Miguel, the stage is on you. Please, people attending, ask questions to Miguel. Don't hesitate to interrupt him, right? Thank you, Miguel. It's yours.
Right. Thank you, Fred. Hi, everyone. Welcome. Thank you for joining. So yeah, this session is going to be about more generally MySQL HA, high availability, and I will talk about two of the major solutions that we have, which are MySQL InnoDB ReplicaSet and InnoDB cluster. So I figured I should start with ReplicaSet because I will tell you why. So ReplicaSet, what we did for ReplicaSet is basically the same we did for InnoDB cluster. We join three components, three products from MySQL, which are MySQL Shell and its admin API to manage, set up, provision, configure, and monitor the setup. MySQL Router to do the transparent routing of your queries from your clients to the right servers of your database. And underneath all of that, the replication technology, which is group replication for InnoDB cluster, and the classic asynchronous replication for ReplicaSet. So I figured starting with ReplicaSet, why? Because asynchronous replication is there for a very long time, many years, and it's a solid technology, and people use it in production. I mean, in a lot of places, it's very widely used. It's very solid, and it's there for a long time. So the thing with the asynchronous replication is that in the past you had to set up everything manually. You had to do to create the users, the replication users, to set up the instances, to set up your master, your sleeves. Well, now it's your source and your replicas. Let me be using the right terminology. And you would have to rely on either write your own scripts to handle things such as failover, or rely on some third-party tools, or do manual intervention. And there was something in the past to do some things, which were the MySQL utilities. Those are EOL'd. And the funny thing is that in the last few months, we have ReplicaSet since 8.19, right? And in the last few months, I've noticed that there was people from the community and also internal customers asking about the MySQL utilities and asking things like, so what happened with MySQL Replicate? That was this utility to set up replication. Or how can I do the failover now if MySQL REPL admin, if I recall correctly, is gone? How can I do that? Why aren't those things integrated or available in the shell, which is a new thing? And my answers were like, well, they kind of are. It's the whole new product. It's MySQL InnoDB ReplicaSet, and people were surprised. They were saying, but that's the admin API. That's for InnoDB cluster. We don't want group replication. We want classic asynchronous replication. And yes, that's InnoDB ReplicaSet. So that's the new thing since some months already. And I figured I should start by showing how to go from an existing setup into a replica set. So for that, I deployed some instances using DB deployer from Giuseppe. I did the manual setup of replication. Let me show you. I have here an instance running on 3301. So this is my master. Not much to see here, and I have 480, 3320. Save the password, please. Show slave status. I have this this replica running with a 3310 as the source. All good, all up and running. The same for this other one running on 3330. Save the passwords for me, please. Show slave status. Same story, right? So this is a very simple topology with one source and two replicas. And now I will show you how to go from that into the replica set so you can enjoy and make use of all the nice things it brings. So using the shell, I'm not going into details about the shell. So there was a talk about the shell of Mr. Fred, and you can see it online. And let me just show you how to do. So the admin API, it's automatically initialized within this DBA object. So you can see that there's a lot of commands. You can access the helper for it like this. You can see commands are available and more information. So to create a replica set is as simple as create replica set. I'll call it DBA May. And this is going to give an error as expected, and it's telling us that this instance has some extraneous replication channels. So there's 3320 replicating from this instance, 33302, and then there is this note saying unmanaged replication channels are not supported in a replica set. If you'd like to manage an existing replication topology, use the create replica set operation with the adopt from AR. This is what I want to do. So this is an option, adopt from AR. AR stands for asynchronous replication, of course. In InnoDB cluster, it's adopt from GR, that is group replication. And using this, the shell will do. We'll start with with scanning the topology. It detects the whole topology. It detects the primary. It detects the instances replicating from it. It does a bunch of checks. It checks if the replication is okay, if the threads are okay, the IO thread, the SQL thread, if everything is fine, and then creates the metadata, updates, and returns the replica set object. This one. And that's it. The replica set is created. And now you can just check his status using rs.status. Well, since I had to increase the font, things get look a little bit weird here, but you can see it. So here's the information, the replica set name, which is the primary instance, the information about each one of them, the primary here, the mode, read, write. We call secondary and primary, the two secondaries here, 3320, 3330, read only, the applier status, the receiver thread status, all good, up and running, and that's it. You can see more information if you'd like using the extended option that can have two values, no, three actually, 0 default, 1 and 2. If you do 1, you get more information such as the fence CSVARs. So on the replicas, super read-only is enabled and read-only. You can get information about the receiver from the receiver thread, replication lag, the server UUID, also the transaction set consistency status. So if one of your instances for some reason has errant GTIDs, the information here will be inconsistent. And if you do extended to, you can get even more information, such as the replication machinery options, connect, retry, heartbeat period, retry count, and so on. So yeah, this is very easy. It's done. And the next step will be to set up the router to do the transparent routing of your queries to the right servers. And to do the route, so first thing you need to do is to bootstrap the router. What does that mean? Bootstrap means you give an entry point to the router of your topology. Can be any. I'll choose the primary here, the 33010, and the router fetches the information, fetches the metadata, and automatically bootstraps itself, configures itself to run against this topology. Using here the /d option, this is to create a new directory where the router stores the configuration and the start and stop scripts. And I'll say here that I also want to use this account. Otherwise, router will create an account automatically, where I say that I don't want router to create accounts. I want to have my own accounts. And for that, the admin API also has commands. So the admin API in general takes care of the handling of all the replication users, the administration users, and whatnot. And also has this command, set up router account, to create an account with the right privileges. So you don't have to worry about privileges. And if those things change, this will be always up to date. And I'll just create, not my admin, my router. I'll just create this account, my router. Yeah, that's it. The account is created. I can bootstrap the router now. Just passwords, and that's it. So the router is configured for the InnoDB ReplicaSet DB AMA. By default, router is listening on two ports, one for read-write queries, another one for read-only queries, and the same for the X protocol. So let me start the router. My router, start. Okay. And just to test things, I wrote very simple Python script. How was it? It's very simple, using the MySQL connector, just connecting to this one to the read-write port 6446, and then doing a select to check to which instance of the topology I'm connected to, this router is connected to, create a scheme if not exists, a table, insert some data, and get some metrics. Very simple. The same, I did the same for the read-only port, just to do a select on the data and print it out with some metrics too. Let me put this run to run. Okay, so here's this app running. It's inserting some data on the primary, which is 3310, and I'm gonna start this one to read. As you can see, so the router by default operates in what's called round robin mode. So it picks each one goes, it iterates through the instances, the read-only instances. So you can see here it's sending a query to 3330, 3320, and so on. So yeah, that's it. The setup is up and running, everything is fine, and now I will show you the things that people really want and that people talk about the utilities. For example, the active switchover, that is electing a new primary for your topology. So right now the primary is 3310, and now using the admin API, it's very simple. You just do set primary instance, couldn't be easier. You select, for example, 3320. I want this to become the new primary. There's a bunch of checks. The admin API takes care of the promotion, and then 3320 was promoted to primary, and you can see here already starting here, the router is already sending the queries to the newly elected primary, and the read-only queries are going to the 3310, 3330, that are the other read-only instances. Here's the status, the new status. You can see that 3320 is the new primary, and the other two are secondaries. So this is very, very, very simple, very, very easy, no big deal, and that's it to change the primary. Now, it's more tricky is the failover. So let's say your primary crashes, you have to do the failover. How can you do it? Let me simulate that first. So the primary now is 3320. I'll use the send kill command of db deployer to kill it. So 3320 is gone, and here already the app cannot send any more queries to it. Let me show you how this looks like. So the shell, the admin API is giving me information saying that the primary is gone, cannot connect to it. So there's also here an information saying you must repair the primary because it's unavailable. And there are here, for example, in each of the secondaries, now you can see this information saying primary instance is not available, but there is at least one secondary that could be force promoted. So this is what we have to do now. There's a command called force primary instance, and using this we can pick one of the other secondaries and elect it, and forcibly elect it to be the new primary. So let me pick 3330, for example. Let's run it, and here's the shell. It does a bunch of checks. It checks the status of the last known primary. it verifies that it's unreachable. It checks if there are transactions pending, and then does the promotion and takes care of everything for the failover. Okay, and you can see the status, and you can see that there is a new primary, the one that I elected, 3330. Router is already sending the queries to it, all good. And if probably you notice that here the read-only queries are only going to 3310 because this instance 3320 is gone. Let's restart it. This is the start script. Okay. And now the status shows something different because the shell already can connect to it. And it's giving us a warning saying the instance was invalidated and must be removed from the replica set. What does this mean? This is how we implemented the solution to be sure that, for example, if the instance is isolated in a network partition, the instance could be online, but from your partition could be seen as unreachable. So you could think, okay, this instance crashed, let me do a force failover and elect a new one, and that could be a problem, and your instance could be in a partition. So by using this invalidated, we ensure that the router doesn't send any queries to it. Also, for example, since this is asynchronous system, the old primary could have executed transactions that still weren't replicated to the replicas, right? And we want to avoid that, so we do this invalidated. We have mechanism with view IDs on the metadata to ensure this. And now you will say, okay, but I know everything's fine. How do I join this instance back to the replica set? Very easy. We join instance D480 3320. Shell will do the checks to verify if the transaction set is compatible, the GTID is fine, and then we'll rejoin the instance to the replica set. And that's it. The replica set is back. And you can see here the application, the read-only, already using the whole of the instances. Okay, what else? Options. So if you the shell is very nice, and you can get information about which commands are available using, for example, not this ReplicaSet.
I have a question for you, Miguel.
Yes.
Because I can interrupt you.
Yeah.
You said
finally,
if everything is fine, it's checking, right? So let's say it happened what you described just before, telling that maybe this instance, so that was the primary before, at extra GTIDs because it has extra transaction, but you don't care about them. You know that. So what will happen when you rejoin?
Okay, you will get an error, of course. You cannot rejoin it, and then you will get instructions on how to figure that out. And if you're sure that you can discard those transactions, you can simply use the clone plugin. So you do ReplicaSet, you first remove it, and then you add it back like this, using add instance. Again, you can select the recovery method. You say clone, and then clone will just wipe out all the data, clone it completely, and add the instance to the replica set. That's what you were asking, right?
Yes.
Okay.
Perfect. Thank you.
Sure. So where were we? Okay, options. Yeah, I was talking about options. So right now we don't have many options, but we have something interesting that is very useful, which are the tags. So you can add tags to instances. For example, I can say that this instance, you can name the tags as you wish. So all primary true, for example, and you get this tag saying, okay, this was the old primary, but right now this is only for tagging, really. There's no doesn't affect the behavior of anything. But there is one which is called hidden, and that we Let me show you. So this tag, it's a built-in tag, and the built-in tag starts with underscore. It's called hidden. It's true. And what this is going to do is to hide the instance from the router. So the instance will keep being part of the replica set. You don't have to do stop MySQL or stop replication or anything. It will just be hidden from the router. So as you can see, the router here is already not sending any queries to this one, 3310, which was tagged as hidden. Remove the tag. It's very simple. Tag hidden false, and the router will start sending queries to it again. This is very useful for things such as maintenance, or for example, the instance is lagging behind a lot and you just want it to catch up and you don't want stale reads from the router, or for example, doing rolling upgrades without having to stop MySQL. And yeah, there are many scenarios this can be useful. So I show you how to adopt. Yeah, go ahead.
Can it automatically reject reads from a replica that's behind?
Automatically, no.
Okay.
No, but that's yeah, that's nice. That would be nice, but no. So I show you how to adopt. I will show you. So, but if you did this from scratch, you will do the add instance command, like I was showing to Fred before. I can show you, for example, let me remove an instance. Let me remove this one, 33.110. Done. And now let me, for example, connect to it. And I'm gonna do reset slave, reset master. Oops. Basically, just emptying the GTID, and I will now add it to the cluster, not the cluster, to the replica set. 80. I want to show you something. So the add instance command has a built-in. So one of the, let's say, biggest and nicest features of ReplicaSet and InnoDB cluster is provisioning using MySQL clone. It fully integrates MySQL clone to do the provisioning. So it's really easy to use. It's really good, and you can the add instance command has a built-in mechanism to detect the GTID state and detect which recovery method will be more appropriate if clone or incremental. Incremental is basically to getting the data from the async channel. And here on this one, the add instance is saying the target instance has not been pre-provisioned. GTID set is empty because I emptied it before. And shell is unable to decide whether replication can completely recover its state. And then it will ask you, you want to use incremental or clone? And you can choose, but I'll just use clone just to show how it looks like. It's going to be, yeah, really fast. There's not much data. So clone, so the shell handles everything, creates the accounts needed for the clone, picks a donor, starts the clone, restarts the instance. So it's all fully managed, automatic. And here's the instance back to the replica set. So yeah, this is how replica set looks like. There's a bunch of more options. You can, for example, see which routers are registered in this one. This is the one I bootstrapped before. You can see the ports, where it's running, the last check-in. This is a health check-in that the router does. This is stored in the metadata schema. Yeah, that's it for ReplicaSet. I don't know if there's any question. Please interrupt me. I'll move. If not, I'll move to InnoDB cluster. So let me stop this up, this one. Let me stop the router to stop. And I've also deployed 3 instances using DB deployer. No extra configurations, anything. So let's see how you deploy an InnoDB cluster. Well, before that, maybe I should talk a little bit about the differences between InnoDB cluster and ReplicaSet. So in InnoDB cluster, since it's based in group replication, you have something that you don't have in ReplicaSet, which is a limitation of ReplicaSet. That is automatic failover. In ReplicaSet, there is no such a thing. You've seen how it was. I'll show you. You have to manually act and elect a new primary. In group replication that is based on Paxos, it has automatic election of the new primary. This is very good advantage of it. Also, in InnoDB cluster, there's no data loss when the failover, when a member happens, and in ReplicaSet, this can happen during an unplanned failover, for example, or during switchover. Another thing, well, this is actually could be a drawback of InnoDB cluster. That is the network. InnoDB cluster requires a stable network. Otherwise, when the network is flaky, members could be kicked out of the group or rejoined. And in ReplicaSet, you don't have such a thing. You don't care for the network. The only thing you can have is stale reads because of the properties of the system is asynchronous. And this is something that you can configure in InnoDB cluster. You can set the consistency of the group, and you can have consistency reads in InnoDB cluster. Meanwhile, you cannot in ReplicaSet. So let me go for the setup. So I have 3 instances running on 3340, 3350, 3360. And the first thing is to run configure instance. That is going to verify the configuration of your instances, and it's going to verify if the instances are ready or not for InnoDB cluster usage. There are a bunch of configurations required. I will show you. Let's run the thing. Localhost 33. Okay, first thing, this is complaining, saying that the user root can only connect from localhost. Gladly, that's how it should be. And the command is telling you that you have some options. You can create a remotely usable account for root. This is not very safe. You can create a new admin account with the right set of privileges and grants. You can ignore and continue or cancel. I'm going to create an account. I'll call it my admin again. Okay, and now, well, this table got a bit unformatted. So this is the configuration options that need to be fixed, so you can run this instance in a cluster. For example, in force GTID consistency, group replication requires this to be enabled. GTI mode 2, GTID mode 2. The server ID has to be unique, and there were more. This list has been getting reduced, which is great because the defaults are changing, and this is very good. But there are still some, and Shell is asking you, do you want to perform the required configuration changes? Yep. Do you want to restart? Yep. Done. The Shell uses the restart command available in MySQL 8 and uses set persist to persist the configurations without the need of getting the path to the MySQL config file and do the changes there. Okay, let me do the same for the other two. Same thing, my admin. And I'm using MySQL 8.21. Okay, that's it. I would like to show you a command that is dba.check instance configuration that you can use to verify if your instance is ready to be used in a cluster or a replica set. It's gonna say, yep, it's ready and valid to be used in an InnoDB cluster. So now you connect to it using that account that I created, the myadmin P480 3340. And likewise for the replica sets, you just use this very straightforward command, create the cluster. I'm gonna call it DBA may IDC. So this is creating the cluster. Done. Cluster is created. We have the C objects. You can see, use describe to see the topology. There's only one instance. Status gives you the information about it. Very similar to ReplicaSet. There's some extra info here. Okay, no tolerance means there is no tolerance for this. Obviously, it's only one instance. We need 3 instances minimum in group application to have tolerance up to 1 failure. So I'll bootstrap the router. Wait, first I'm gonna create the router account. My router. Okay, and I'll bootstrap. Same story. You need to provide one of the instances of the topology. There's only this one in the router account. Done. Let's start it. Okay, and we can start the Python app to do writes, which is not working. Oh, yes, it is. And the one to do reads. Okay, and obviously there's only one instance, so the reads and the writes are going to the same one. So what's next? We need to add instances to the cluster. So using add instance, the 3350. Same story. GTID set is empty. We cannot determine if it's safe or not to use the incremental recovery. So we prompt the users. I'm gonna use clone. I could use incremental because it's an empty instance. There won't be any clashes with the transactions. There's not much data, so clone is really, really fast. Okay. And that's it. The instance was added. Router is already using it, 3350, and we can do the same for the other one. I'm gonna use incremental. Like I was saying, I know that it's safe to use. There are no errant transactions, so I could do Control-C. Oh, was too fast. I could do Control-C and send the process to the background and then verify the status using the status of the recovery using C status. So again, looking at the status, the cluster now is online, can tolerate up to 1 failure. We have the 3 instances. Group application operates in single primary mode by default. That means there is 1 primary accepting read-write transactions and 2 secondaries accepting read-only. You can see here topology mode, single primary. But you can change that anytime if you'd like. You can switch to multi-primary mode. You have to be aware of the risks. But it's very simple. You just do this, switch to multi-primary mode. And that's it. The cluster is now operating in multi-primary mode. All of the instances are read-write. And to switch back, you do switch to single primary mode. And that's it. We're back, same primary. So like in ReplicaSet, we can do the active switchover, which is to elect a new primary. Very easy. Set primary instance. I pick one of them. Let's say 3350. And done. Router is already sending queries to it, and the read-only queries are going to the others. It's very simple. And now the topology here. Now let me show you the automatic failover, which is the biggest feature of InnoDB cluster. So I'm going to kill the primary 3350. Is this one? It should be gone by now. Yep. See here that the primary is gone, and a new one was elected. This one, 3340, was elected as the new primary, and router is already using it for the write queries. So yeah, it's all automatic, and the way a group application decides which one is going to become the new primary is based on weights that can be configured. If you use the options, you can see this is the variable member weights. By default, they're all on 50, so it's the election is going to be based on the UUIDs. That's why 3340 was elected at the lowest, and you can change this at any time using set instance option. For example, T480 member weight, I'll say 100. Or oh no, this is the one that was done. Set to 100, so this one is going to be the new primary whenever failover happens. Now let's bring it back online. Start status, and here it is. Recovery in progress. The instance is joining the cluster. Yeah, and that's it. There's not much data, so it's pretty much instant. And the instance automatically rejoins the cluster because we persist all the settings, all the group settings. So the instance has this option, which is group replication start on boot. And whenever the instance goes back, it will start group replication and rejoin the cluster automatically. So yeah, that's it. The same story for hidden instances. You can use the set instance option, hide instances. In cluster, there are more commands. Right now, you have things such as force quorum using partition off. This is whenever you lose the quorum. So if in this case, if two of your instances are gone, you lost the quorum. So group replication cannot elect a new primary. So quorum is lost, and you have to pick the partition on which you want to force the quorum using this command. If all goes down, should never happen, but if all goes down, you have this one, reboot cluster from complete outage. It will look at the metadata and will recover the cluster based on the configuration that was stored in the metadata. I already showed switch to single primary, switch to multi-primary. If you would like, this is something for security. So the recovery accounts, the replication accounts in InnoDB cluster are managed by the shell. You don't have to worry about it. It's created automatically. We use secure passwords, randomly generated. But if for some reason you need to refresh those passwords, you can use this command, reset recovery accounts password, and it will create new passwords and refresh those accounts. Yeah, that's it. I don't have anything more to show.
I have a question then, Miguel.
Yeah.
Not a question, but because I know a bit about it, but there is some shell parameters or option, right, in the command line that are not well known by people or not often used, like the primary and the cluster. Could you show it and explain about them?
The primary and the cluster? You mean the command line integration?
Yes. Well,
what I'm doing right now?
No, when you connect to a cluster member, you can specify a cluster, so it will check if the machine is part of a cluster, and it will create the global cluster for you. The object.
So yeah, so yes, you start the shell with this, and then you specify this minus cluster. No, sorry. how was it?
Yeah, it's minus cluster, but no space, I guess.
Oh, okay, 3 for
if I remember correctly.
Yeah, that's it. So yeah, when you so what I did here was to start a shell binary to provide the URI for one instance, and using / cluster. What does this do is to connect to that instance and verify if that instance is part of an InnoDB cluster, and if so, it will start the cluster object, and you have the cluster of object of that instance available to you. The same for ReplicaSet. I have a ReplicaSet running here in 3311. Oh, ReplicaSet. Yep. So you have the RS object of your ReplicaSet. It's very useful. And something I wanted to show too is the command line integration. So if you have if you want to write scripts, if you don't want to use the shell interactively, you can write scripts to do operations, and you can use a command line integration. So it works like this. Cluster and, for example, status, and it will print in your shell, in your terminal, the output of the command. Or you can do remove instance or add instance. You have all the commands available in the command line, in this command line integration. Yep. So, any more questions? It's very quiet.
Yeah, I like that demo you gave just there. I wonder if there's a way to like get the cluster object and also switch the connection to be whatever the primary is.
Yep.
Like connect to one of the.
Yep, you can do that using my memory.
Redirect primary.
Yeah, are you sure?
Yes.
Redirect.
Yeah, but you also it's a command. It's an option.
Yes,
so
dash redirect dash primary.
Yeah.
Redirect dash.
Yeah, that's it. Right. Thank you, guys. So yeah, this will switch the connection to the primary. You can do redirect secondary. If for some reason you want the shell to connect to a secondary member, you notice here that I was providing the URI to the primary, but actually the connection went to one of the secondaries. This can be useful for, I don't know, up to you.
Yeah, that's awesome. Thank you.
Yeah, sure. Yep. Okay. Anything else?
It's so easy, right?
Yeah. And nothing failed.
Giuseppe, I remember you pasting a question into the channel before. Did you get to ask that one, or? Let me pull it up real quick.
It was about why we are putting together ReplicaSet and InnoDB cluster instead of having a separate talk about ReplicaSet.
Yeah, that's a good question. Well, from my point of view, it's because there's the same admin API for both, so it behaves similarly. In the shell, you can manage things in a very similar way. The commands are very similar: add instance, remove instance, status, describe, set primary instance. So the goal here was to show the deployment of both, show how similar it is, the deployment and management, and show the differences regarding the replication technologies underneath, the lack of automatic failover for ReplicaSet, and these other differences. That's the reason we bundled together the two technologies in the same talk. Or I hope it was the reason.
Okay. Just a simple question, since you said that everything was simple. Are you going to publish the scripts or the configuration that you used for the demo?
Sure, I can publish, but the config. I just use the RDB deployer, nothing fancy.
Yeah, okay, but if I say DB deployer, give me the demo from Miguel, it doesn't do that. So I would like some guidelines.
Sure. I can do it. And I can also publish the scripts. This simple Python application to do the writes and the reads.
Inspiration for many people, including me.
Okay.
Thanks.
Sure, I will do it. Yeah. Thanks for the feedback.
Great.
Yeah, I have another question. So I know that as you're doing the commands, it's kind of procedural, right? You're using a JavaScript or a Python language.
Yep.
What do you say to people that want to control infrastructure in a declarative way? Like,
Sorry, I don't understand. What do you?
A lot of deployment tools use declarative language,
Yeah.
where they describe the topology and not, a scripting interface to get to that topology.
Yeah, well, people can use this command line integration that I show you, but probably what you're asking is something different. Maybe what you're asking is that what if the admin API would be a module that could be imported in Python, so you could access to it, right? I think that will make much more sense, but at the moment that's not possible. But that's something that quite some people asked about, and I think it will be nice to have. But priorities. Yeah. I didn't show the Python mode, by the way, but it's very simple. You just switch to Python like this. You switch to SQL, JavaScript. And you have the admin API is only available in Python and JavaScript modes interactively in the shell. Yeah.
I mean, since you can code your own scripts, you could probably just make basically a YAML file, then just wrap.
Yeah, you can do that. And I've seen people, for example, integrating this in Ansible and Puppet. Just doing calls to the shell binary with the command line integration, and it works. I've seen that. There is room for improvement, of course, so we're working on that, but it's possible, yeah.
I have a question. Same as Morgan, when you have the commands, is there a help or a kind of a quick FAQ or cheat sheet that for the rest of the commands?
Yeah, so you can start here with the /mark or /help. It will tell you the main help categories: admin API, shell commands, shell API, xdev API. If you want, since we're talking about admin API, you can do like this. You have the general intro of the admin API. You have here examples of the command line interface. You have the objects that are initialized in the admin API, the DBA1, and then the two classes, cluster and ReplicaSet. And then you can access the help for those by doing this. Okay, have here the commands available in DBA. And for example, if you want more information about a particular command, you can do, for example, create cluster. And you have here the online, we call it online helper, and has the whole information of this command, the syntax, what it returns, the description, and the list of options. All of them, it's quite a lot of options. This is for group replication. And then there is more details about the options. For example, here's the adopt from GR that I talked before. SSL mode. All the information is available here. Yeah.
Cool. Thanks.
You don't have to go to the website and check the online.
Yes,
help.
this is helpful because you won't remember all these commands.
Exactly. Yeah. And it's growing. The admin API is growing. Yep. More and more commands coming in.
Okay. Do you think you can demo the recovery if all the nodes fail?
If what?
All the nodes fail. Kill all your servers. So
yeah. Okay. So which one? ReplicaSet or let's kill the. Oh, not start. Send
well,
kill.
so you don't need the. Well, I mean, with the ReplicaSet, it doesn't. There isn't really a quorum. I mean, you don't need to. Well, I don't know. Sorry.
You want to know how to recover from a complete disaster?
Yeah, just like if all of the InnoDB cluster nodes go down, say you have a power loss in your data center or whatever, and you have to use the forced recovery option, so it looks at the metadata. I'd just like to see how that works, if you don't mind.
Well, sure. I can show you. Let me kill them all. It's quick. And 6. Okay, so let's wait a few seconds. Okay. And now I will start them back, right? You need to start them to recover. So 4, 5, and 6.
But you killed them cleanly with -15, right?
Okay, I could use -9, but
Yeah, but
do you want me to do it?
if you do a disaster, this is what would happen, right?
You're right. You're right. That's a good point. Okay, that's a good point. Maybe Giuseppe could have this send kill disaster mode. All right. So let me connect to this one. And now, if you do a cluster equals dba get cluster, you'll get an error saying this is a standalone instance. Metadata exists. Instance belongs to that metadata, but GR is not active. So what we do here is this reboot cluster from complete outage. Command will, like I was telling you, look at the metadata and see what is there and what was the configuration. We like to call a metadata a letter of intentions. And then it will ask you, hey, I found this one. 33450 was part of the cluster configuration. Do you like to rejoin it? Yep. Same for the other one. And the active session. Okay. So this is good. It's a protection. It's telling me that this session is not the most up to date. It doesn't have the highest GTI set. So I'm going to use, and it tells you which one has 3306. So you have to connect to it. T480 3360, and the same thing. And the command will reconfigure everything, restore the instances, rejoin them back to the cluster, and it shouldn't take much. That's it. Cluster. I'm glad I left the app here working so you can see the router doing its job. Yep.
Very cool. Thank you.
You're welcome. So
Miguel, we're approaching the top of the hour. I might stop the video, but if you don't mind staying on for a couple minutes, maybe there's some questions users were hoping to ask online. So thank you again. It was very entertaining.
It was a pleasure.